Sorry. Yes, it's a long slide, but basically this is we've been working on a sequence to image left atrial fibrosis. So atrial fibrillation is the most common arrhythmia, and left atrial fibrosis has been known to be the substrate for its initiation and maintenance. Previous studies have shown that left atrial fibrosis, as measured by late gadolinium enhancement, can be used to help predict the recurrence of AFib in patients getting an ablation. Unfortunately, these imaging sequences are subpar due to several things. They have a lower spatial resolution, which is difficult to measure the thin LA wall. They use respiratory gating, making the sequences very long. And finally, many use 3D scanners, which makes it more clinically difficult to translate. Therefore, we wanted to develop a high-resolution, free-breathing 3D LALG pulse sequence using stack of stars K-space sampling and XD-GRASP reconstruction for quantifying fibrosis in the LA at 1.5 T. And some of our important imaging parameters is that we're at 1.5 by 1.5 by 2 millimeters, and our scan time is around 6 minutes. So here are just some examples of our imaging of the 3D LA-LGE compared to the standard 2D LGE in the clinical standard. And you can see that our imaging has much higher resolution, and we can actually see enhancement in the LA wall. We had two clinicians that were blinded score our scans compared to the standard, and we have a significantly higher conspicuity of the LA wall. And finally, here are just some examples of our imaging and that can be used to quantify LA fibrosis, and our values are comparable to what is seen in the literature. Thank you.